Okay, so I'm going to show you how to solve homework problem number 2 from section 12.5. I have created a MATLAB coding, and this video is going to show you step by step how to use that in order to solve this homework problem. So the first thing that we would like to do is go to a browser and then type in the web address vlab.ung.edu. It is going to ask you to sign in. After you have signed in, you will see the page that you are seeing right now. Click on Virtual Lab. If it is full, then you can go to Virtual Lab Overflow 1. If it is full, go to Virtual Lab Overflow number 2. Once I enter Virtual Lab, it's going to show you a UNG desktop page, and the next step for you will be to go to the library folder, select the U drive, go to classes, instructors, das.b, and then select our calculus 3 class, and you will see the int.sim.m MATLAB coding. Double click on that. It's going to open the MATLAB page with the coding, and we're going to solve our problem using this code. So that's the coding. You see the double prompt here, and we're going to work out the problem here. So let me show you which problem I'm talking about. This problem says that consider the graph of the vector valued function rt equal to ti plus 4 minus t squared j plus t cubed k on the interval closed 0, 2. Now, some of you will have a different but similar type of problem. The numbers 4 and 2 will be different for you. So I'm going to solve this problem, and you have to change your own version and do it in MATLAB. So the first question is asking me approximate the length of the curve by finding the length of the line segment connecting the endpoints. So the endpoints will be for the point 0 and for the point 2. This function, this vector valued function, looks like x of ti plus y of tj plus z of tk, where x of t is t, y of t is 4 minus t squared, z of t is t cubed. So how do I use MATLAB in order to solve this problem? First, when you are on the MATLAB page, go and run, and it's going to show that it is using the InSync program, and it is asking you to type in the xt function. Remember, my xt function was just t, so I will put t there and hit enter. So it will ask me for the yt function. My yt function was 4 minus t squared. I typed it in, enter. It is asking for the zt function, so I will go ahead and put t to the power 3, enter. Then it is asking for the lower limit. In my problem, the lower limit is 0, so I put 0, enter. Upper limit is 2 for me. I put that in, enter. Then it is asking for sub-iterations. Since I am only using the lower limit and the upper limit as the 2 points, I have exactly 1 iteration. So I'm going to put 1 and hit enter. So what it has done, it has given you the graph of the function, and it has also answered your question for the approximate arc length, which is 9.165151. So let us go back to our problem, which we were trying to solve. And this problem says round your answer to 3 decimal places. So if I look at the answer that I got from the MATLAB coding, I will see that the answer is 9.165. So Let's put that in. .165 rounded up to 3 decimal places. Then it is saying use some of the intermediate points. So it is saying that find the arc length between R0 and R0.5, R0.5 and R1, R1 and R1.5, and R2. So if I think of how many subintervals I have, R0 to R0.5 is 1, R1 to R1.5 is 2, and R1.5 to R2 is 3. So I will run the same MATLAB coding, but this time the number of subintervals I'm going to use 3. So let's go ahead and do it. I put CLC to clear the screen and I enter. So now we're going to run the code one more time. Similar information, you're going to put T, then you're going to put 4 minus T squared, that's your Y. Then you are going to put T cubed, that's your Z. Lower limit is still 0, upper limit is still 2. Number of iteration, I'm going to use 3. And it will show you each step how the values are changing. So after all this work, the final approximation of the arc length is 9.497 rounded to 3 decimal places. So let's go ahead and put that in. 9.497. Describe how you could obtain a more accurate approximation by continuing process A through B. So generally, it is like the Riemann integration processes that you have learned in your Calculus 2 classes. You increase the number of sub-iterations. So I'm going to pick that answer. So it is saying increase the number of line segments. That's increasing the number of iterations. So I'm going to click on that. And finally, it is saying to use a graphing utility to approximate the length of the curve. So what does it mean? You do this iteration for bunch of number of times. For example, say 1,000 times and see what happens. So I'm going to go ahead and show you in MATLAB how would you do that. So first and foremost, I am on MATLAB and I'm going to clear the screen by saying CLC. Run the program one more time. For xt, type in t. For yt, type in 4 minus t squared. For zt, type in t to the power 3. Lower limit is still 0. Upper limit is 2. And remember I said I will use 1,000 iteration for this problem to closely approximate the arc length. Now this is going to take a little bit of time to complete the entire process because it is going to calculate the same problem for 1,000 times. So let's hit enter and see what is happening. So as you can see, the number of iterations is changing. We're still under 100. And as I said, it is going to take a little bit of time, so we'll be a little patient. All right, so we completed the process. Let's round our answer to 3 decimal places, and it's 9.571. So we're going to put that answer in, 9.571. Oh, it said 5 decimal places. So, and the previous one was 4 decimal places. I'm so sorry. So let's go back and see. 5 decimal places gives us what? 9.57057. So let's see that. 9.57057. And this answer was 4 decimal places. So I have to run the code one more time. Should not take much time. And then run it. Xt is t, yt is 4 minus t squared, and zt is t to the power 3. 0 lower limit, upper limit 2, iteration 3, and round to 4 decimal places. I will get 9.4974. And what I will do, I will try to check my answer and see how far away from the right answer we are. And let's see. So it says that I have done almost all of it right, but with a little mistake. So let's see which part I did not do right. Okay, let's see. It's just the second one. It says that I didn't do it right. So I will go ahead and check my work one more time. I think I did almost all of it right. So it was 9.4974. And I was using 1, 2, 3. Oh, see, I was using 4 intervals, sub-intervals. 0 to 0.5 is 1, 0.5 to 1 is 2, 1 to 1.5 is 2, and 1.5 to 2 is 4. So 4 sub-intervals. So we'll do the MATLAB coding one more time. I'm so sorry for the miscommunication. So let's see. Run the code. T 4 minus t squared. T cubed. 0, 2, 4, and round to 4 decimal places will be 9.5293. And let's do it one more time. I think it's saying that I have done all of them right. I want to check it. So yes, so all of the parts are right. So this is a little bit of training that we wanted to learn in our class, how to use MATLAB to simulate integrations in finding arc length of functions.